We're looking at the sum. K goes from 0 to infinity. We're going to look at 2 to the 2k plus 1 times x plus 1 to the k over 2k factorial. All right, so a nice little power series. And once again, folks, you got to remember here, so you don't panic, 0 factorial is defined to be 1. So anytime you have a factorial in the denominator and you got a 0 down there, it's fine. 0 factorial is 1. Okay, so before we get going, what's the center here? What's the center of convergence going to be? Well, when it's x minus a, the center is a. Here we've got x plus 1. So that means the center is what? Well, negative 1, right? X minus a negative 1. So when we do our interval of convergence, we expect whatever interval we get to be centered around negative 1. So let's set up the ratio test here. A sub k, that's the kth term. And let's look at a sub k plus 1. Now, once again, when you go to do this substitution, you either want to mentally or literally take the k, wherever the k is, and you want to envelop that in parentheses. And you want to erase the k in parentheses and replace it with the quantity k plus 1. So this would be 2 to the 2 times the quantity k plus 1 times x plus 1 to the quantity k plus 1 over 2 times the quantity k plus 1 factorial. And so what you get here is 2 to the, when you distribute that 2k plus 2 plus 1, 2k plus 3 times x plus 1 to the k plus 1 over 2k plus 2 factorial. So this is an opportunity to make a common error. And so you just want to take it one step at a time. Okay, I spell these things out in gory detail because I know that's where the mistakes tend to get made. Any questions on determining the AK plus 1 there? So let's set up the ratio there. AK plus 1 divided by AK. So we've got 2 to the 2k plus 3 times x plus 1 to the k plus 1 all over 2k plus 2 factorial we're dividing by a sub k, so we're dividing by this fraction. We're going to multiply then by the reciprocal. 2k factorial over 2 to the 2k plus 1 times x plus 1 to the k. So as always, we group together what goes together. 2 to the 2k plus 3 over 2 to the 2k plus 1 times x plus 1 to the k plus 1 over x plus 1 to the k times 2k factorial over 2k plus 2 factorial. And now we simplify. Once again here with these exponents, when you divide with the same base, you subtract the exponents. So this is going to be 2 to the 2k plus 3 subtracting 2k plus 1 Be mindful of the exponents. Here it's easy to see k plus 1 minus k will just give you x minus k to the first. And as always, when it comes to factorial, remember the mantra, when in doubt, write it out. You always want to start writing out the larger of the two factorials because the smaller factorial should eventually turn up in there. So if I start with 2k plus 2 factorial, I start with 2k plus 2, and I multiply it by all the numbers that come before it. So the number that comes before 2k plus 2 would be 2k plus 1. Subtract 1, then 2k, all the way down to 1. And if you look in the numerator, 2k factorial is 2k times all the numbers before it that go to 1. And so we can simplify this. 2k plus 3 minus 2k plus 1. That's going to leave us with a 2 squared, x plus 1. All of these will cancel, and I'm left with the denominator of 2k plus 2 times 2k plus 1. So that's our ratio there for the ratio test. Any questions on simplifying the exponents or the factorials there? So yep, you can simplify this to 4x plus 1 over 2k plus 2 times 2k plus 1. And now we're all set to run the thing off to infinity. Limit as k goes to infinity of the absolute value of a sub k plus 1 over a sub k is the limit as k goes to infinity. And remember, the absolute value works well with multiplication, division, and powers. So the absolute value of 4 is 4. All the k's are positive. I only need absolute value around that quantity, x plus 1, because that's the only thing that could possibly be negative. And what happens here is k runs off to infinity. Well, hopefully this might remind you of the take-home assignment, because this is the same kind of thing that happens on your take-home due tonight. As k runs off to infinity, remember the 4 and the x plus 1, they're just constant as far as k is concerned. The denominator is running off to infinity. So this ends up being 0. And we'll go ahead and put a little smiley face there, because that's always less than 1. So the limit as k goes to infinity of the absolute value of ak plus 1 to ak is always 0, which is always less than 1. So by the ratio test, the power series, k goes from 0 to infinity, 2 to the 2k plus 1, x plus 1 to the k over 2k factorial is always absolutely convergent. So the interval of convergence is minus infinity to infinity. So technically speaking, I suppose you could think of that as an interval being centered at -1, but then what would the radius of convergence be? Well, they would call that an infinite radius of convergence. So the radius of convergence is r equals infinity. And they do call it that. So it's an infinite radius of convergence. That means it converges everywhere.